All right, welcome back everybody. We're going to take a look now at vectors again. So I'm returning to this vector concept. But we're going to see we need our discussion on determinants in order to do this. We've already talked about dot products of vectors. Now we're going to talk about what we call the cross product. In fact, let me make that really big. Right? This is the cross product of two vectors. I'm taking this first vector, maybe that's vector A, and this is vector B, and I'm going to cross them together. So what I'm interested in is A cross with B. I'm interested in A cross with B. And what I'm going to get, we're going to see this, what I'm going to get when I do this cross product is another vector. And what's really cool about these three vectors, A, B, and the cross product of A and B, is that the cross product of A and B is perpendicular to A and it's perpendicular to B. When we say that it's mutually perpendicular to A and B, it's mutually perpendicular to the two vectors that created this cross product vector. Now the way we evaluate the cross product of two vectors is with a determinant. And this works out pretty straightforward. I got a determinant. And it does matter whether A or B comes first, right? So A cross B is not equal to B cross A. Turns out it's the negative, so it's the opposite. But if they're not equal, there's a nice relationship, but they are not equal. And the way we work this is we put in the elements of the two vectors, but we start off with the top row being I, J, and K. And so what we're going to see is we don't get a number when we evaluate here. We get another vector. Then I put in the elements of A, the X component, the Y component, and the Z component of A in that order, X, Y, and Z. And then I do the same thing for B, the X component, the Y component, and the Z component. Right? So the vector A is 6I hat minus 4J hat plus 2K hat. X component, Y component, Z component. So if for some weird reason your matrix is not, or excuse me, your vector is not written in the proper order, you've got to put it in the proper order. And then negative 2I hat, negative 3J hat, positive 7K hat. Right? So that goes there. Okay, then to make life simple, I'm going to write this out, I hat, and then the minor for I hat, J hat, then the minor for J hat, and then K hat, and the minor for K hat. Sorry for the level change. Okay, so I hat, take out the row and the column, I'm left with negative 4, 2, and negative 3, 7. J hat, take out the row and the column, I'm left with 6, 2, and negative 2, 7. And then K hat, take out the row and the column, I'm left with 6, negative 4. And negative 2, negative 3. And then the plus minus plus rule, I hat is plus, J hat is minus, K hat is plus. I hat is plus, J hat is minus, K hat is plus. And so what do I get? I get negative 4 times 7, that's negative 28, minus 2 times negative 3, so minus negative 6. And all of that is multiplied by I hat. I put it in behind instead of in front because it's going to want to be there when I write it in vector format. Minus 6 times 7, which is 42, minus negative 4. And then the K hat. Then plus 6 times negative 3, that's negative 18, minus negative 4 times negative 2 is positive 8, so minus 8. And there's the K hat. And so continue there. I have negative 28 minus a minus 6 is plus 6, so that's negative 22 I hat. 42 minus a minus 4 is plus 4, so that's 46, but don't forget the minus sign there. So minus 46 j hat. And then negative 18 minus 8 is going to be negative 26 k hat. And that's a vector. And that vector is the cross product of A and B. Here's A, there's B. Right? That's the cross product of A and B. Real quick aside, B cross A is the negative of A cross B. So B cross A would be equal to 22I hat. Right? Just change the sign. Plus 46J hat. Plus 26K hat. Okay, so it's the opposite. It's the negative of it. But that's how you do cross products using determinants. That's how you do it using determinants. Okay? And I put numbers in there. We could put in generic A sub x, B sub x, A sub y, B sub y, A sub z, B sub z. But I don't want to do that. I'll just leave it with numbers. I'll let you do that. What if I had, I'll even write it out. What if it was A cross B? So I hat, J hat, K hat, A sub x, A sub y, A sub z, B sub x, B sub y, B sub z. And then you could evaluate that. It'll all be in terms of these letters. But that would be the generic form for A cross B. But I always just put it into a determinant. I could write this out as a formula, but I just like to put it into a determinant. Makes life very simple. Okay? And again, this vector is perpendicular to A and it's perpendicular to B. Okay? And we'll talk about the right-hand rule and how that points in a different video. All right? So hopefully that'll help you do cross products. I can show you how to do it on your calculator as well. But that's how we do cross products with vectors, three-dimensional vectors. We won't get into anything else. Two-dimensional vectors are kind of boring. All you have to do is put a 0 here and a 0 here. And what you're going to see is, I'll just talk about it for a second. If I put a 0 in for A sub z and a 0 in for B sub z, the I hat, I get 0. The J hat, I get 0. And so I only have a K hat. So if it's two-dimensional, it's two XY vectors, the cross product points in the K hat direction, points in the Z direction. Right? So if I had an X here and a Y here, and here's A hat, and here's A vector, and here's B vector, it's going to point out of the board or into the board, in this case out of the board, and you will just evaluate these. It's going to be a number, right? It's going to be AX times BY minus AY times BX, all times K hat. So it's going to point out of the board or into the board. In this case, A cross B will point out of the board. We'll talk about how I know that in a later video. All right, if you have any questions on the cross product of two vectors, please leave them in the comments below. Thank you.